Bela ma'am, am I audible?
Yes, yes, you are very much audible. Hello, Dr. Kamlesh Jangit. Good evening, sir. Hello, Rasika. Yeah, hello.
Good evening, Bela ma'am.
Yes, good evening. Good evening,
Yes.
Patel sir.
Good evening.
Good evening, Deshmukh sir.
Good evening. Good evening. Now you can add incoming members.
Yes, sir. They are getting added automatically. They are
Yes.
getting added, and I think I can have already. Dr. Jangid is the co-host. So
Yeah.
I think he can.
He can share the screen now.
Yeah, yeah. Hello, Dr. Kamlesh.
Good evening, ma'am.
Good evening.
Yeah.
Good evening, sir.
Good evening, Dr. Sanjeev. Yeah, I was just trying to change some settings to see which of the headphones work.
Yeah, it's working.
Yeah. Okay. Am I clearly audible?
Yes, yes, very much.
Okay, great.
Hello, Dr. Kamlesh.
Hello, ma'am. Dr. Rasika, right. Yeah. Yeah, we've interacted quite a lot earlier.
Yes, sir. Yes.
Yeah. I was talking to Bela ma'am the other day when we met at Nagpur, and then ma'am told me that, you are her PhD student.
Yes.
Yeah.
I completed my PhD under guidance of Dr. Bela ma'am.
Okay.
Nitin, can you forward the YouTube link to our student groups also?
Yes.
Yes, ma'am. Yes.
Nitin, do that. Yeah.
Yeah.
Ma'am, is it okay if I just share my screen to see which?
Yes, yes, you can do that.
Yeah. see which one is the green. Now you can see my full screen, right?
Yes.
Yeah. Okay.
Yeah, it is very much visible.
Just want to share for some.
Good evening, sir.
आणि कुणाकडे अटक मंगेशकर माझा
The participants are joining, so we'll just wait for everybody to join.
Sure, ma'am. No problem.
पुढचे झाले करणं कम्प्लीट कंटाळा आला का असं करू नको तुला काय प्रॉब्लेम आहे का मग
ते कसं करतात ग?
Bella ma'am, you can start now. Hello, Bella ma'am.
Yes, sir. We'll start.
You can start now. It's
Yes,
7 minutes past to 7.
sure. Rasika, can you, I will just call Madam, Principal Madam, if she is joining.
Yes.
I think it's not possible. They are in a meeting, so they have asked us to start. Go ahead with the program. So Rasika, you can start the program.
Yes, ma'am. Good evening, one and all. I, Dr. Rasika Pawar, your host, is pleased to welcome each and every one of you to a brainstorming lecture on guidelines for identification, nomenclature, and deposition of novel archaea and bacteria isolated from India. Before we get started, let me throw some light on purpose of this lecture. The upsurge of technology in sequencing has revolutionized the classification and identification of novel archaea and bacteria. We as microbiologists are in immense need to update ourselves about the latest advances and new guidelines in microbial culture identification and deposition. Hence, this lecture is organized to make us all aware about the current advances in the field. May I now welcome Professor Dr. Bela Nabar, Madam, Head Department of Microbiology, Srimati CHM College, and State President, Microbiologist Society India, to introduce the session to the audience. Over to you, ma'am.
Thank you, Rasika. So hello everyone, and a very good evening to all of you. Myself, Professor Bela Nabar, I'm the head of the Department of Microbiology, and very happy to be the State President of Maharashtra and Goa for the MBSI. So on behalf of the HSNC board and the Srimati CHM College, I extend a warm welcome to all gathered here. It is our privilege to have our linkage partners from MBSI, Dr. A.M. Deshmukh sir, Dr. Patankar sir with us, and would also like to extend a special welcome to Dr. Kamlesh Jangir. I also extend my warm welcome to dear principals, vice principals, and head of the departments, researchers, MBSI members, and other regional coordinators, teachers, and my dear students for this program. I would like to share a few highlights of my department. The department is established in 1970, and we have a doctorate program since 1977. It also caters to UG, PG, and PhD programs. And one plus point is our research department is permanently affiliated to Mumbai University, and it has been sanctioned 20 research seats. we had 3 major research projects, 29 minor research projects, 6 research guides, and output of research is 25 PhDs and 50 MSc research students from this department since 1977. The department is also coordinating an NAMP SAMP project of MPCB, which also has the Earn and Learn scheme for students to the tune of 26 lakhs per year. We have collaborations with MBSI, Masina Hospital, UASD Dharwad, Grey East Technology companies for research projects. We have several workshop and certificate courses to enhance the skill set of the students. And for last 3 years, we have been winning the Avishkar Trophy for that is the Mumbai Research Convention program. And we have received the Best Department Award national level from MBSI. Now regarding today's seminar, what a webinar is on the new guidelines for identification, nomenclature, and deposition of the archaeal bacteria which we isolate. Now, every researcher usually dreams of identifying a novel bacteria and depositing it in the NCTI repository. Now, taxonomy is identification, classification, and naming. But the standard procedures, which are slightly changed, are being made aware here with the esteemed personality which we have with us, that is Dr. Kamlesh Jangid. I'm happy to tell you that he is a scientist, he's a teacher, as well as an industry person with citations more than 2,500. His H index is 20. He is with us today giving us his valuable time. So I hope this talk will be very useful to all of us. So thank you very much, Dr. Jangid, for accepting this. And I think instead of we will go ahead with the program. So thank you very much. Rasika, you can take it over.
Thank you, madam. I now welcome Dr. Arvind Deshmukh, President, Microbiologist Society India, to share his views and guide us. Over to you, sir.
Thank you. Thank you, madam. In fact, I will not take a time because everyone is eager to hear him. Only what I want to tell. Bela Nabar ma'am heard his lecture at Nagpur.
Yes.
And she felt that it should be again popularized throughout the India. Let me tell you, we have circulated YouTube link also. In every group, in 40 groups, I have circulated YouTube link. The reason is that our quota is only 100 and it is full now. So, for others, wish all the best for today's program. Thank you. Thank you.
Thank you, sir, for your kind words. May I now call upon Dr. Sanjeev Patankar, National Convener, Microbiology Society India, to address and enlighten the gathering. Over to you, sir.
Hello. Actually, good evening to all of you. And as Dr. Deshmukh sir said, many of us, we heard to Dr. Kamlesh Jangid at Nagpur. And it was the common thought that it must be popularized all over the country. So I congratulate Dr. Bela Nabar madam to organize this webinar immediately after the conference is over. And I am also thankful to you all for joining. I am not taking much more time. And as Dr. Deshmukh sir said, and also Dr. Rasika Pawar, she emphasized why this particular type of the webinar and such type of the lecture it is necessary. So without wasting much more time, I conclude my words. Thank you, and over to you, Pawar.
Thank you, sir, for your encouraging words. I call upon Dr. Pranali Shetty to introduce Dr. Kamlesh Jangid, President, Burgess International Society for Microbial Systematics, and Head, High GX 360 Sequencing and Bioinformatics, High Media, Mumbai. Over to you, Dr. Pranali.
Yes, am I audible?
Yes, you are.
Okay. Good evening to one and all. It gives me great pleasure and honor to introduce today's speaker, Dr. Kamlesh Jangid. Sir is currently working as head in sequencing and bioinformatics, High Media. Prior to this accomplishment, Sir has been a senior scientist at NCTS Pune and a visiting scientist to University of Toronto, Canada. Sir has also been a fellow at University of Georgia, Canada, and Ohio State University, USA. Dr. Jangir has been awarded with several national and international awards, like the Albert Nelson Marcus Lifetime Achievement Award. Sir has been honored with the prestigious position of Secretary and President for the Burgess International Society of Microbial Systematics. Sir has been awarded with research and travel grants from esteemed institutes like NSF USA, Chinese Academy of Agricultural Sciences China, and SERB India. Moreover, Dr. Jangir is on the editorial board of several renowned journals like PLOS, Frontiers in Microbiology, Soil Biology, and Biochemistry. Sir has over 60 publications with very high citations in reputed journals to his credit. Sir has been an invited speaker in numerous national and international conferences and has guided several master's students from India and abroad. Actually, this is a very, very humble introduction to Sir's credentials, and I have tried to do justice to it. Sir will be enlightening us on the topic guidelines for identification, nomenclature, and deposition of narwhal archaea and bacteria isolated from India. Thus, with this brief introduction, I would like to welcome Dr. Kamlesh Jangir to share his knowledge with us. Over to you, sir.
Thank you, Dr. Bela, ma'am, Dr. Patankar, Dr. Deshmukh sir, and Rasika and Pranali for this nice introduction. I would like to start without wasting much time. And the topic that I've chosen is very dear to my heart. It's basically relates to microbial taxonomy, and the reason I chose will be sort of evident in the next couple of slides. The topic is guidelines for identification, nomenclature, and deposition of novel archaea and bacteria isolated from India. And the reason I removed the new word from the title was because these guidelines have been in existence for about 3 to 4 years now. Quite unfortunately, the information has not percolated to our Indian microbiologists, and that's why we as a society, which is the Burgess International Society, has decided to, do outreach activities throughout the world. And as part of that, I decided to present the work at the first conference of the MBSI held in Nagpur. I belong to a firm, and everybody is aware of that Burgess Trust. We as microbiologists are quite aware and very fascinated with the Burgess Manual. So the trust was established in 1936 by David Burgess, Robert Stanley Reed, and Everett Murray. And these are the three pioneers who decided to establish a firm for ensuring that the microbial systematics takes good shape and is a core field in the microbial system, in microbiology as such. The Burgess International Society was established in 2006 when the idea was originally conceived by the Burgess Manual Trust. And finally, the society was established formally in 2009 through a vote, and 2011 the constitution was approved. The society was erected with an idea to promote research in microbial systematics, as well as to enhance global communication and advocate for research efforts in the field of microbial systematics and diversity. These are the current officers of the society, and myself as the president since August 2020. And we've got an excellent team of Professor Wenjun Li from China, who is the secretary, who took over from me once I became the president, and then Professor William Whitman, who's from University of Georgia. He's also the editor, chief editor for the Burgess Manual, and also happens to be my postdoctoral advisor. So as part of the outreach activities, we conduct a lot of outreach workshops, and one of them, the core one, is the Business Live activity. The Business Live is basically an online seminar series that is held every third Saturday of a month, and it happens at 12 p.m. IST. It happens through a Zoom link. You can register at this short URL, or you can scan the code. The next meeting of this Business Live is on the coming Saturday, on Saturday the 18th. And the lecture will be delivered by Professor Christa Schlepper from University of Vienna. This is our third year of this series, and we've had excellent speakers. The session is dedicated to eukaryogenesis. So the participants can register for this activity. It's a free online activity that you can register. So as part of business, we've been trying to ensure that microbiologists in the community are actually aware of what's happening in the field. So I'm going to touch the three basic topics of taxonomy, which is classification, nomenclature, and identification. I hope I'm able to share the screen.
Yes, you can, sir. You can share the screen.
Yeah.
Yes, sir, it is visible.
Yeah. So the three interrelated parts of taxonomy. I think this particular slide was not visible, so you can scan the QR code to register for the Business Live activity that I was talking about. And I think I skipped over a couple of slides because my screen was not shared. So this is what I was going to talk about. And basically, as a classification, it is the field that talks about the arrangement into groups for different organisms. And then nomenclature is the field that has assignment of names to those organisms. And identification is determining the identity of an organism only after an organism is classified. And it kind of addresses the more important question, like what is the name of the bacterium in front of me or the bacterium that I'm working with. As part of all of these, one thing that I would like to point out is that prokaryotic classification as such has no official classification. So there is no official classification of prokaryotes. The one that you know of, the Burgess Manual of Determinative Bacteriology, was published as a manual, which was a work in progress. And it was published with an only goal that it is not an authority for systematics, but it serves as an advocate or as a vehicle for the improvement of bacterial classification. So this was published in 1923. And this year we are celebrating 100 years of the publication of the first manual. And once that was published, then we came up with the first edition, which was published, the first volume was published in 1984. And over a period of about 7 years, up until 1991, a lot of other volumes were published throughout this first edition. As you can see, for about 7 years, the publication was only progressing as part of the first edition. And this actually causes a lot of delay in disseminating the information from, from research lab to text, and from text to the educational institutes that work across the globe. And the second edition, in a similar scenario, the first volume was published in 2001, and the final volume was published in 2012. So over a period of 11 years, the second edition was running. And what has happened over these years is that the advances in molecular methods have taken a rapid pace. So you've had the culture-dependent methods and microscopy that were originally, somewhere in the 1850s, they were originally started to be used. And then molecular phylogeny picked up in the 1960s. And then DNA sequencing and 16S RNA approach picked up in the 1975. And by about 1977, the PCR method was picked up. And then the culture-independent methods picked up suddenly. And today we are at a stage where we are actually using whole genome, multi-locus sequence alignments, and ANI, multi-top. These are the newer methods that we use for bacterial identification or microbial identification in general. And as you can see, with the introduction of the 97% 16S RNA gene sequence similarity threshold, sometime in the 1987, that's when the identification or the description of new species started to pick up. So that's something that has led to a significant increase in the number of taxa that are described. And what it has led to is a field called dynamic taxonomy. So microbial taxonomy or microbial systematics is a dynamic field that have hundreds of new genera or 600 plus new species that have been described during the past 5 years of the publication of the Burgess Manual second edition. And to provide an up-to-date description, the Burgess Manual Trust decided to bring up a digital edition in 2015. And this is the new edition of the Burgess Manual of Systematics of Archaea and Bacteria. This is a digital-only edition. That means there are no print editions to this. You have to subscribe to this through wileyonlinelibrary.com. And in order to get an complimentary access to this publication, you can also become a member of the Burgess International Society and get access to this manual. But basically, this is the manual that is currently being used as a guide to do classification based on a systematics approach or an evolutionary approach. And the evolutionary approach comes from the the work of Wolfgang Ludwig, who has delivered the ARC software and the Silva database that uses the 16S as the basic, backbone of this evolutionary framework that is used in the systematics manual. So currently, whatever you are doing or whatever you are identifying is based on, the 16S identity at a scale of 97%. But that has changed over the past couple of years. And what it has led to is a change in the field of prokaryotic nomenclature. And as I said, with prokaryotic classification, as there is no official classification, there is fortunately an official nomenclature of prokaryotes. And the official nomenclature of prokaryotes is actually governed by, a couple of rules. So names are given to prokaryotes which are regulated. And the regulation actually happens through a bacteriological code, which is the International Code of Nomenclature of Bacteria. And its successor is called the ICNP, which is the International Code of Nomenclature of Prokaryotes. Now this, or what we call as the code, is governed by a committee, and the committee or the body that oversees this is called the International Committee on Systematics of Bacteriology, or the successor is called the International Committee on Systematics of Prokaryotes, or the ICSP. So the ICSP is kind of the formal authority that has devised the rules of nomenclature for organisms that are available in pure culture. And quite unfortunately, with the ICSP as well, or the ICNP, which is the code was revised in 2008, and it took about 11 years again to publish this code. And the revision code was published in the 2019 edition of the IGSEM, which is the final journal where you can publish taxa, novel taxa, or you can describe new methods of identifying and classifying organisms. So this ICNP, or the code, was published in 2019. And there are several limitations to this code. The first one is the LPSN, or the code basically describes organisms based on a rigid framework of nomenclatural code. And I'll go over why this nomenclature code has limited publication of taxa. But before I move on to that, I would like you to be aware of something which is called an LPSN database, or the list of prokaryotic names with standing in the nomenclature. So what this list does is it provides accurate information, latest information that is available to to us as researchers, and it provides the current status of a name, synonyms, other useful information related to that particular organism. And this list is currently maintained by DSM, which is the German Culture Collection of Microorganisms. And LPSN is basically based on valid publication of taxa under the rules of the ICNP. Now, what is this valid publication of names? Now, under this valid publication, currently the LPSN has about 19,000 species, roughly about 3,300 genera, 670 subspecies. Now, all of this includes also some candidatus names, which is about 380 candidatus names of species. Now, this valid publication or the concept of valid publication is very tricky. Now, why is it tricky? Is because a name has no status and no claim to recognition unless it is validly published. And by validly published, it means that the name has to be cited and the name must be designated or the taxon must be designated. By cited, what it means is that the name must be present in the approved list of bacterial names, or it should also be published in the IJSB or the IJSEM, which is effectively a validly, an authorized journal that publishes new taxa under the validation list. And by designated, it means that the culture that you are describing as a novel taxa has to be present in at least 2 publicly accessible service culture collections. And that's something that causes a problem in the field. And the problem is that there are other nomenclatural codes that also allow publication of taxa or species that are only available today as specimens. So the type in ICNP is primarily defined, originally was defined as a description is a preserved specimen or a preparation or an illustration. That means anything that was known but is now non-existent, even fossil records could be published validly. Unfortunately, the 2008 revision of the ICNP removed this flexibility and they put this rigidness that the culture must be viable and it has to be present in at least 2 publicly accessible culture collections in different countries. And this is the restriction that causes a problem, especially for organisms that we know now are the dark majority or organisms that are present in uncultured form, but we know that they exist. So there are a couple of problems that first one is most prokaryotes have not been brought into pure culture because they cannot be validly, and so they cannot be validly published under the rules of the ICNP. So there are roughly about 18,000 bacterial species, but one of the biggest drawback is roughly about 95% of organisms cannot be cultured in the lab. The second one is most prokaryotes are fastidious and cannot be maintained by culture collections simply because the expertise is not available with the culture collections. They are only available with certain labs that work on those particular organisms, and they've been working for decades. Like for this example, I'm citing Nitrosopumilus maritimus, which was isolated in 2005 as an organism only under the microscope, and the genome was sequenced in 2010, and it was validly published only in 2017. So this particular organ, as you can see, took about 12 years to publish under the rules of ICNP. Similarly, there is a new problem that we as a few of the Asian countries face, is that the implementation of the National Biodiversity Law that is restrictive under the Nagoya Protocol or the Convention of Biodiversity. Under this law, some prokaryotes cannot be transferred between countries. And if you recollect, I've already mentioned that publish an organism as a valid publication, you have to submit it to international culture collections. And so because of all of this, publication of pure cultures or isolates has become a problem, especially from the Indian context. So there was a proposal that was floated in 2015 where genome sequences were proposed to be used as type material for taxonomic description of prokaryotes. There was a lot of debate on it, and there were a lot of meetings that happened about it. And some of the meetings actually looked at the advantages and disadvantages of this particular proposal. So as you can see, with a pure culture, you have an unambiguous reference to a type species. And obviously, the genome also provides the same kind of confidence. The experimental value of a pure culture is also very high. The experimental value of a genome is quite moderate, but it's not. It's definitely not as high, but it does provide high enough confidence because of the source of the lab experiments and all that. The ability to scale to all taxa. That means if you have an organism from a particular genus, the availability of a genome of that organism allows the implications of that particular genome to the entire genus, rather than only limited to that species or the strain. Similarly, archival performance or permanence of that particular genome sequence is much higher. The accessibility to a genome sequence is much higher. And the interoperability, that means the flexibility to work between different labs, is also much higher. So as you can see, the overall advantage of organisms described from taxa or from genome sequences is much higher as compared to pure culture. So obviously, with this thought, a new code, which is a parallel code to the ICNP. Let me clarify here that it is a parallel code to the ICNP, but only for pure cultures currently. So it allows you to publish, new species under a code called seq code, which is a nomenclatural code for prokaryotes described from sequence taxa. This code was put in effect on the 1st of January 2022, and many new species have been described from this. So the seq code is a code of nomenclature where the type of a species is a genome sequence. And this is the seq code committee that governs the implementation of the seq code. And the slides that I'm using today are kindly provided by Phil Hugenholz, Louis Rodriguez, and Barney Whitman for the presentation. And these are the three, some of the key members of this seq code committee. There's a small comparison that I'm going to present between the ICNP and the seq code. As you can see, the criteria of authenticity or a type is a viable culture under the ICNP. And for the seq code is a DNA sequence which is deposited in the INSDC database and is cited in the online seq code registry. The registration of names is through a publication in IGSEM. And for the seq code is through the seq code registry. The compatibility of names is through LPSN, which requires manual curation. And this is done in the seq code through a seq code registry, which allows easy access and can also allow search and retrieval of information. The number of taxonomic ranks included in the LPSN currently above the rank of genus are 9, whereas in the seq code it is only about 4. But as you can see, overall, the entire seq code is in parallel and can also accept organisms which are also described from pure cultures. And this has come as a, as a help or a boon for researchers from India. I'll go over that. So to get to the seq code registry, what you have to do is you have to basically search through a database of all names of prokaryotes for comparison to the proposed name. That means the name that you are proposing. So you basically search through a repository. And if you don't find that name in the repository, that means the name you are proposing is novel. So you can go ahead and propose a name and its type, that means a genome sequence, to this particular seq code registry. The registry automatically does automatic checks, and the name is reviewed by a curator, which is maintaining the C code registry. To tell you about the automated checks that happen in the C code registry, the automated checks, there are total 52 automated checks that happen. It checks across different codes. That means the botanical code, the zoological code, and the ICNP code. And it gives you whether your name is original. It also does a similarity check to other names. It also does the check for length and pronunciability, grammatical consistency, rank coordinated suffixes, and to type material. Now, I would like to highlight the length and pronunciability once to all of you. Like you can see these names which are actually, published or approved and validly published in the under the ICNP. Now look at this name, Clostridium saccharoperbutyrylly nicum. It is even difficult to pronounce. How do you even name an organism that is so difficult to pronounce? Now look at this Myxococcus, blah, 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 blah. This is an organism that has a name containing about, 72 characters. So it's very difficult to pronounce names, many names that are published under the ICNP. The C code takes care of all of this. It doesn't allow anything longer than a 2 vowel and 2 consonants. So once the name is approved through automated checks and reviewed by a curator, the author is notified of an approval and the name is included in an effective publication. And by an effective publication, it means that the name receives a DOI immediately, and the author is notified that the C code is accepting that. And under that new name, you can directly publish your organism in any of the journals that are available, not unlike the ICNP, which only considers, a valid publication if it is published under the IGSN. So to get to the C code registry, you can actually go to this website called seqco.de. This is the website that will, allow you to undergo the entire process of entering your names into the C code registry. There are few requirements before you submit your organism for the data quality. There are few organisms that the type, genome, or the assembly quality has to follow at least 90% complete and less than 5% contamination. And this also is applicable to for isolates. You must have a read coverage which is over 10x and an agreement between the genome and 16s based taxonomic assignments. Now, if you are publishing a metagenome assembled genome or a MAG or a sequence assembled genome or a SAG, the criteria is very stringent, so you cannot publish anything rubbish. For the recommendations based on 16s, for the MAG, it must have a 16s similarity for the 75% of the completeness, and passes the camera check with over 80% tRNA present. With the high genome integrity, you must have greater than 100, less than 100 contigs with an N50 value of over 25 kilobases, and the max contigs length are must be greater than 100 kb. So the MAG and SAG read coverage, as I have already pointed out, it should be over 10x. For the INSDC data availability, the assembly must be available in the INSDC database, and the raw data must also be available in the INSDC database. So with all of these, requirements and recommendations, you can submit your data to INSDC, and you can also publish an organism under the C code. Where we go from here now? So basically, we have gone through all of this, that we have written the C code, we've created the C code registry. Now the challenging task is to merge the nomenclature of the ICNP and the C code. What it is do is that it will allow a formal nomenclature of the cultured and uncultured taxa to be brought under a unified framework and foster the development of synergies between the microbial disciplines of molecular biology biochemistry, physiology, systematics, environmental science, and ecology. So with publication of many new novel uncultured organisms, there will definitely be a need to make new organisms, so or name new organisms. So that's something that we have already taken into consideration. And this is a roadmap for naming uncultivated archaea and bacteria. This was already published. Under this roadmap, an automatic software or an automated way of defining names has already been published. And this was published in the December issue of 2022 of the IJSEM. And this is basically a software capable of defining 65,000 candidatus names with utmost accuracy. And those names can be devised within less than 1 hour. So you can imagine the kind of credibility and the computational intensiveness that has undergone into building this software package. There is new changes into the taxonomy of organisms or the nomenclature of organisms that have recently been recently impacted with the valid publication of the names of 42 phyla of prokaryotes. So what this has done is the phylum names like the proteobacteria, firmicutes, bacteroidetes that you know are no more valid. They are based on, instead, new names have come up with a suffix of ota and that carry the prefix from the type genus of that particular phylum. So with this, the most affected, phyla are the Bacillota, which was originally called the firmicutes. So the firmicutes must now be, designated as Bacillota, or the nomenclature has changed. Similarly, the proteobacteria are no more called as the proteobacteria. They are called as Pseudomonadota because the first type genus published under the proteobacteria was Pseudomonas, and so it carries the Pseudomona from there and Pseudomonad from there, and ota is the the suffix that goes with the phylum name. So Pseudomonadota is what we know as proteobacteria, and the Bacillota is what we know as firmicutes. Similarly, there are new, updates that are coming in soon. There is a debate happening on the names of the classes. Recently, a proposal was floated just yesterday about the inclusion of the names of domains and kingdom within the rules of the ICNP. So soon you will see that the three domain classification that we know as bacteria, archaea, and eukarya will probably formalize. So these are the changes that have happened in the field of nomenclature, and you should be aware of that. Similarly, the changes in identification have happened. The field has moved from polyphasic to genome-based. As you can see, the methodologies for characterization of prokaryotes have evolved quite a lot, and they give you a different, level of resolution. As you can see, for whole genome sequence analysis, it can give you resolution starting from superfamily to family, genus, species, and strain level. So these are some of the methodologies that have undergone drastic changes. We know that the correlation between DNA hybridization and 16S similarity, we basically use to identify organisms based on 97% sequence similarity up until very recently. So the changes have impacted drastically. Now that we have access to genomes, what it has led to a significant description of novel taxa in a very short period of time. So, until the 2000s, we used to have about, 600 organisms per year. Today, we have about 3,789 organisms, published every 7 months. This number has drastically increased with the, access to genome sequences. So genome sequences, the definition of bacterial species has evolved drastically over the past decade. and integrating genomics into the field has led to what we know as average nucleotide identity. Instead of a single gene-based identity, today we do or define an organism based on an ANI value, which is currently updated. So as you can see, there are proposed minimal standards for the use of genomic data for taxonomy of prokaryotes. The organism is no more 97% cutoff. It is a 98.7% cutoff for the 16S similarity based on the genome sequence. The overall genome related index must have a 95 to 96% average nucleotide identity with a 70% of digital DNA hybridization, and a phylogenomic tree with at least 30 genes that need to be described based on the genomic sequence. And based on this, you can describe your organism as a novel species. Now, genome taxonomy database is the database to go because this is the most enriched database for genome sequences. You can go to this database and you can see that there are roughly 311,000 bacterial genome sequences. This is as of July 2022. And there are roughly 6,000 archaeal genomes. Obviously, this number is pretty old, and you can go to this gtdb.ecogenomic.org website. University of Queensland, the database is hosted by Phil Hugenholz, who was the first inaugural speaker of the Business Live Talk. And this is the workflow for the genome-based data description of novel species. As you can see, you have to obtain a full-length 16S sequence from that genome, and then you do a search, you identify the phylogenetic makers, and if the sequence similarity is less than 98.7, it automatically becomes a new species. If it is over 98.7%, you can calculate the overall genome relatedness index using ANI and 70% VDH. If it is if it is above these values, then it is a known species. If it is less than 96% or 95% or less than 70% digital DNA hybridization, then it becomes a new species automatically. So based on the genome sequences, this is how you describe the organism. For the next part, which is, if you have a cultured isolate that you still want to publish, and the cultured isolate happens to be from India, there is a problem. And the problem is you have to maintain a balance. The deposition of isolates of Indian origin must, follow the accessibility and benefit sharing criteria and ensure compliance to these two criteria, which are governed by a couple of authorities worldwide. I'll quickly go over these things. Now, the deposition of organisms is governed by a couple of rules internationally. The first one is the Convention on Biological Diversity, which was established in the 1992. And in 1992, this CBD, India became a party to this CBD. And because of India becoming a party, India has to follow Nagoya Protocol, which defines the rules of access to genetic resources and the fair and equitable sharing on benefits arising from their utilization. And this is, governed by the CBD. Now, because India is a signatory to the CBD and follows the Nagoya Protocol, India established what we call as the National Biodiversity Authority in 2002 and came up with the National Biodiversity Law. And that was enacted in the Parliament and approved in 2003. And the website for all of these organizations are cbd.int and nbaindia.org. So you can visit this website to read more about it. Now, what happens in the Nagoya Protocol is that under the Nagoya Protocol, the benefit sharing part restricts the NBA, which is contradictory to the Nagoya Protocol, not contradictory to the Nagoya Protocol, but part of the CBD, and it follows the Nagoya Protocol, ensures compliance by implementing an access fee to an organism, which is deposited even in India or outside, but is of Indian origin. So under this, what happens is the IGSEM, because we are supposed to deposit the organism into two publicly accessible culture collections, the IGSEM under the Nagoya Protocol can no longer accept the proof of deposit of type strains originating from India, South Africa, and Brazil. Because under the NBA rules, the the Biological Diversity Act 2002 prohibits any non-Indian from accessing biological resources of Indian origin, and deposition of any microbial culture in a culture collection outside India by an Indian researcher also requires a prior approval from the NBA, that is the National Biodiversity Authority. So under this, access of an Indian origin culture requires prior approval from NBA. This is considered as restricted access and not free access by the ICSP, which is the committee that governs the rules under the ICNP and under which you can publish in the IGSEM. So because of this, the microbe hunters, are concerned over the research in peril, especially in India. So basically in 2016, NBA issued this notification, and this notification restricts the deposition of organisms into publicly accessible international culture collections from India. And other culture collections, because of this notification, because of this restriction of free access, have now stopped accepting cultures from Indian researchers or Indian origin. So we raised this concern to the National Biodiversity Authority, and the NPA finally implemented or set up an expert committee in as per the section 39 of the Act. And they established this expert committee, which met in the year 2017 and then again in 2018. And eventually, this authority, looked at this problem, and they approved certain designated culture collections in India to start accepting cultures and deposit these cultures on behalf of Indian researchers to outside culture collections. But the problem still exists that even to access a culture from outside, that culture is at odds with the Indian law, because the law act requires that the non-Indian researchers who want to access cultures originating from India, even those stored abroad, must obtain permission from the country's NBA. Now, this obviously has to create a balance between accessibility and benefit sharing. Now, because these cultures are only available for taxonomic purposes or research purposes, there is no benefit, commercial benefit to this. There is only a research benefit that you require these cultures to do comparisons with, other novel taxa or other reference cultures that are available for that organism to be described as a novel species. Now, to take care of all of these, differences, what has happened is the NBA has considered all of these factors. And today, if you want to publish an organism from India into, or deposit an organism from India into an outside culture collection, you are supposed to have, followed the NBA guidelines. And the NBA guidelines propose that to access a culture, whether it is deposited outside or in India, but is of Indian origin, the person who wants to access this culture must apply in Form 1, which is available on the NBA website and can be applied online through this absefiling.nic.in website. As you can see, the timeline is 180 days. That means for up to 6 months, NBA is going to deliberate, and once they approve, then your application will be approved. Obviously, there is also a fee. That means it is not freely accessible. So it contradicts some of the laws of the ICNP, and that's why the culture cannot be accessed. Now, to come over to your part, which is as a depositor of the cultures to these culture collections, you have to follow the guideline of applying in Form C. Luckily, you don't need an approval from the NBA, and you only need to intimate the NBA by submitting this Form C on their website, which is this abscfiling.nic.in. Lastly, this is the website under which you can also access cultures for research or deposit cultures for research to international culture collection. Somebody has a mic open. Yeah, so you can also deposit these cultures to international culture collections if you follow the appropriate form filing through Form C or the Form 4 to transfer the access biological resource to a third party. That means to an international culture collection. So you have to fill up this form. If you have to access this culture, then the form needs to be filled is Form 1. And if you need to deposit a culture, you have to submit Form C in India. And if you have to deposit this culture or access a deposited culture internationally, you have to submit Form 4. Now, this is the website which is, run by the NBA, under which if you go to this at the bottom of the page, you can go to this reference corner and you can go to the user manual, you can go to FAQs. And based on both of these documents, you can very clearly, follow the process of the filing under the NBA. They also have a very nice video under which it tells you how you can, follow the process to submit these cultures. So eventually, prokaryotic taxonomy has undergone a lot of change. And because of this lot of change, following all of these things is not possible, but you can contribute to the change in the prokaryotic taxonomy by ensuring that you are aware of all of these latest changes, and you can become aware by becoming a member of the Burgess Society. This is, a chargeable fees, but there are different rates to student and faculty. But even if you do not want to become a member or pay the fees, you can participate in these live sessions that are conducted by BISMIS. And under these live sessions, we have already discussed the renaming of the phyla. We have already discussed the C code a couple of times. We have discussed the new nomenclatural, changes. We have discussed the class level changes. We have also discussed the problems that microbial ecologists are facing because of these nomenclatural changes. Soon we will have a session on how these changes are impacting the clinical diagnostics field. So all of these sessions are conducted by international experts, and you can register for this latest session that's coming through this short code, and automatically you will be registered for the remaining talks of these sessions, and you can be more aware with those recent changes that are happening in this field. And with this, I will close, and I'll be happy to take any questions. I acknowledge the Burgess Manual Trust and the Burgess Society, for which I'm the president and that I represent. Lippincott Williams, who were the original publishers of the Burgess Determinative Manual, and then Springer, who were the publishers of the Systematics Manual, and Wiley, who is now publishing the BMSAB. iMedia, where I work currently, and microbiallab.org. That is my research lab that I was running until last year. So with this, I'll close and I'll be happy to take any questions. Thank you.
Thank you, Dr. Kamlesh. It was indeed an amazing lecture, and it gave us insights about latest advances and new guidelines in microbial culture identification and deposition. Thank you so much for a very crisp and knowledgeable talk. We now have a question and answer session. So I call upon Dr. Ashish Jain to take up questions for discussion. Over to you, sir.
Am I audible, madam?
I think it's wobbly.
Hello.
Yeah, now it's better.
Hello. Am I audible, madam? Am I audible,
Go
sir?
ahead. Yes, you are right. Go ahead. Yes, you are right.
Yes. Thank you, sir, for a wonderful talk and lot of information you have shared with us. So we have a few questions in the question box. So I'm reading those questions. Is there an online service available for establishing the identity of a given isolate? One question.
There is no. Basically, there are a lot of resources by which you can do genome comparisons, or you can do in silico DNA hybridization. You can do phylogenomics using core gene sets, or you can do 16S based identification. Like there's a website called Easy Texon. Easy Texon allows you to do identity search based on genome similarity. So you can identify your organisms based on Easy Texon. DSMZ has its own resource of doing genome comparisons. So there are a lot of resources by which you can calculate all of these different parameters that are required to identify an organism as a novel isolate. Eventually, the scientific decision or the intellectual inputs come from your own self, where you can only identify the organism based on these different comparisons. So yes, there are online resources by which you can calculate all of these different parameters, but then the eventual decision is typically based on the flowchart that I just showed, and the flowchart will guide you whether your isolate is novel or not.
One more question is there. If a culture has less than 97% similarity with the known cultures, so do we need genome sequencing to publish it as a novel?
The thing is, if a culture has less than 96% similarity, this will lead to an indication that your organism is novel, but it will definitely not give you a confidence based on a single gene that your culture is indeed novel. There are certain organisms that require a lot of other assays or tests to be done to describe a species as a novel. Definitely, it will give you almost a 99% confidence that your culture is indeed novel. And obviously, if you do a genome sequencing, that genome sequencing will allow you to have a better confidence, and you will be able to publish it as a novel species. But I'll tell you, if a culture can be cultivated and if it is not only known from genome sequences, you should do all biochemical tests, you should do all microbiological tests based on what are the required parameters for that particular taxon, to which genus it belongs, to which family it belongs. And you must use all the distinguishing parameters if it is a pure culture. If it is a metagenome assembled genome or an uncultivated organism, definitely you will need the genome sequence to publish it as a novel organism.
Sir, one more question is, is fatty acid?
I think the audio is breaking, but I can read. Is the fatty acid profiling mandatory to confirm the novelty of a bacteria? Yes, fatty acid profiling is required. Depending on the taxa, there are certain markers that are used to identify organisms that are required to be distinguished as novel taxa. So yes, fatty acids are required to describe organisms as a novel taxa, depending on the taxa your organism belongs to.
Sir, one more question is there. You have mentioned 52 automated check. So one participant knows some detail about it.
Sorry, can you repeat that question, please?
Yes. Can you, sir, elaborate 52 automated check that you have mentioned in your talk?
Okay. Yeah. So those 52 automated checks, let me just quickly go over that. Yeah, so these 52 automated checks, when you submit a new organism name to the C code registry, the registry has an algorithm by which it carries out automated checks on that new proposed name that you are giving to your organism. And this registry will ensure that the organism follows the right rules. It also ensures grammatical correctness. It also ensures similarity to other names, that your organism name is not similar to any other name that is that is already existing. So it ensures all of these 52 checks that are present in the algorithm to ensure that the organism name you want to give is very, very unique, and it only is given to one organism in the entire tree of life.
Sir, one more question is there. We have to pay any cost for deposition of sequence?
No, there is no cost to deposit the sequence. Obviously, there is a cost to do the whole genome sequence, but there is no cost to deposit the sequence.
Is Ashish, there is question from YouTube also.
Can I ask a question? Can I ask one question?
From YouTube also.
Can I ask something?
Yes, sir.
It was a wonderful talk on identification of cultures and preservation of cultures in a very scientific way. We need to conserve microbial diversity very well, because in the future we'll be losing many strains which we have today. So it is very important to identify new microbes which produce antibiotics, for example, because by 2050 all the antibiotics will not work. So we have to look for new antibiotics from archaea and from bacteria before 2050, so that very few people die. So this is a very, very important field, conservation and identification of microbial diversity. I have one question. There are some endangered species of archaea and bacteria. What is done to take care of them and preserve them in a good culture collection?
Professor Swanjeet, you worked at IMTech Chandigarh quite a lot, and you know that MTCC was the first IDA that was established. Recently, what has happened is the interest in archaea was long existent, but the interest has jumped drastically in archaea because of their, unique physiology and how they are able to deliver new bioactive compounds. Your question is very relevant, that what are we doing to grow or to protect endangered archaea species?
Yes.
Endangered archaea species, they are not only archaea, there are many bacteria which are not known, which we have not been able to grow. So I think there are labs like Professor Ito, who has been working on archaea, has recently discovered a new Asgard archaea. The next session that's coming up at Business Live is Professor Krista Schlepper, and she's worked on Asgard archaea quite a lot. Unfortunately, the expertise in culture collections for such fastidious organisms is very, very limited, and that is why many culture collections do not have the facilities to grow these organisms or the expertise to grow these organisms.
Yes, yes.
The simplest example is anaerobic cultures. In India, there are only 2 culture collections that have, out of the 30, that have few anaerobic cultures. Most of these anaerobic cultures are actually present in non-formal research labs across India.
Yes.
And preserving biodiversity is something that is there was an article that to preserve a single strain of organism annually, the DSM spends about 482 euros per year per culture.
Right.
And if you look at the cost of recovery from a culture may be purchased once in 10 years. So if you look at that cost and convert it to the Indian scenario, you are looking at roughly 480 euros converts to 4,800 rupees per year. And culture collections need money from the government because they cannot be, self-reliant. The number of cultures that are being, asked by researchers across by supply of cultures, a culture collection cannot make that much income that is required to maintain the cultures. So, maintaining an expertise and maintaining the kind of facilities in a single culture collection is not going to be possible unless the government realizes this, drawback. Unless culture collections are funded, we will not be able to preserve this diversity for long unless we rely only on those experts and few experts that are left all across the globe to preserve this diversity.
That's right. Government has really to fund all the cultural collections so that they can identify and conserve like acidophile, alkalophiles, microaerophils, anaerobic cultures, like you said. So government should really understand and fund the cultural collections very well. Thank you.
Yes. Yeah, my pleasure.
आर्टिफिशियल इंटेलिजेंस सिनेमा और साहित्य के व्यक्ति पर प्रभाव जैसे कई मुद्दों पर चर्चा करेंगे।
Are there any more questions that you would like me to take, ma'am? Dr. Rasika, would you like me to take any more questions?
So there is one question. I will just read to you. Is submission of sequences to gene bank and obtaining the accession numbers no longer considered for publication?
No, that's not true. Submission of sequences to GenBank and obtaining accession numbers is still required to do any publication related to genome sequences or to single gene sequences. The only difference that has happened or that will be implemented soon is that the Indian government is implementing a policy called I think it is in silico data policy or digital data policy, in which the digital data policy will ensure that sequences that are generated from Indian resources are deposited into Indian database, and the Indian database is going to have like GenBank, EMBL, and all of these international data banks. The accession numbers are interchangeable. That means if you have one accession number, you can search for that sequence in all of these databases. Similarly, this new database is likely to implement a similar scenario where these sequences will be available through the interexchangeability between these databases. So as far as I am aware, the deposition to NCBI is still okay, but as soon as this new policy is implemented, I think it is going to be restricted.
Thank you, sir.
Yeah.
I don't think any questions are there anymore. I think all are very happy with the topic they have given their listing. They have a very informative lecture. I think Rasika, you can continue further.
Thank you, ma'am. Thank you, Dr. Kamlesh, for answering all our queries. I call upon Dr. Sandhya Mulchandani to propose vote of thanks. Over to you, ma'am.
Thank you, Rasika. Am I audible?
Yes, ma'am.
Good evening, one and all. I am Dr. Sandhya Mulchandani, Assistant Professor, Department of Microbiology, CHM College. It gives me immense pleasure to present the vote of thanks. First and foremost, I would like to thank HSNC Board and Principal Srimati CHM College who permitted us to organize the webinar. Thank you, ma'am. I would like to thank MBSI President Dr. A.M. Deshmukh and National Convener Dr. Sanjeev Patankar who collaborated with Microbiology Department for organizing the webinar. I would like to thank Dr. Kamlesh Jangir who removed his precious time from his busy schedule to enlighten us about the latest developments in nomenclature and deposition of cultures. Thank you so much, sir. We were introduced to very new terms we are not acquainted with, just like ICSP, LPSN, ICNP, then concept of valid publication and 52 automated checks. Very big thank you from the entire Department of Microbiology. I would also like to thank Team Microbiology Department for their efforts put in for the webinar. I would like to thank our Head of Department, Dr. Bela Nabar, who took the initiative to organize this webinar. Last but not least, a very big thank you to all the participants, including HODs, researchers, students, who showed their overwhelming response to attend the webinar. Once again, thank you, sir. Thank you very much.
I think we can on the videos for taking a photograph. If possible, all participants can on their videos, even the teachers of the department. Participants, if you can on the videos. Kamlesh sir, participants have asked for the PPT. Can you share the PPT so that we can send it to them if it's visible?
Yeah, that's okay. I can convert it to a PDF and share it.
Yeah, no problem.
I guess the lectures are available on YouTube as well, right?
Yeah, now today it is recorded on YouTube also.
Yeah.
So they will have the access to the YouTube also. It will be there regularly.
Yeah, but I'll send it.
Yeah, sure. So thank you, sir. It was a very informative talk. Thank you, Patankar sir. And all my team members who have done the work in spite of having a college fest for last 2 days. They have really given time and done a very great job. Thank you, sir. And I think we will be troubling you, sir, for any difficulties we have, because many are PhD students and researchers and guides. This is something new for all of us and we need some help. So we will
No problem, ma'am.
Okay.
No problem. My lab actually does sequencing on as a service, so that is also possible.
Sure, sir.
If we can have your email ID, we can put the queries there.
No problem. I think email is there with.
Yeah, I have the email ID and even details.
Yes.
I think you have even given me brochures of the iMedia in the conference. So
Correct.
I have given it in my department. I will put it on the group otherwise. So everybody else also can.
Yeah, sure.
Okay. Thank you, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you.
As it is aptly said, end of the story is a new beginning. On this note, let's conclude the memorable and knowledgeable event and look forward to many more of such lecture series organized under the aegis of Microbiologist Society India. Thanks everyone for attending the event. Thank you so much.
Thank you.